What if we're not alone? For years, scientists believed Mars was just a dead, frozen desert, but NASA just discovered something that could change everything we know about life in the universe. Our story begins on a world millions of miles from our own, in a place sculpted by a forgotten past. This is Jezero Crater on Mars. 3.5 billion years ago, this vast dusty basin was a deep, tranquil lake, fed by a powerful river that carved a channel through the crater rim. Over millennia, that river deposited sand and mud, building a massive fan-shaped delta, a geological feature that, on Earth, is exceptionally good at preserving the delicate traces of past life. This is precisely why NASA sent the Perseverance rover here. Its primary mission, to be a robotic astrobiologist, systematically searching this ancient lakebed for biosignatures, the tantalizing chemical fingerprints that long-extinct organisms might have left behind. For more than 1,000 Martian days, or sols, Perseverance has been meticulously exploring this alien landscape. It's a slow, deliberate process, guided by a team of brilliant scientists and engineers back on Earth. Every rock is a potential history book. Every grain of sand, a possible clue. The rover's journey has been a marathon of patience, inching its way up the delta front, analyzing the terrain, and drilling into the most promising targets. Then, in a region nicknamed the Margin Unit, the rover's cameras locked onto a peculiar target. It was a pale, finely layered boulder, about the size of a briefcase, that had likely tumbled down from a higher cliff face. The team named it Cheyava Falls, after a waterfall in Arizona's Grand Canyon. At first glance, it might have seemed unremarkable, just another rock in a field of rocks. But to the trained eyes of the mission's geologist, it was special. Its fine-grained sedimentary structure suggested it was formed from silt and clay that settled gently at the bottom of the ancient lake. This was exactly the kind of environment where organic matter could be rapidly buried and preserved for eons. The decision was made. This rock demanded a closer look. With commands beamed across the void, Perseverance maneuvered into position, its 7-foot robotic arm unfolding like a surgeon's toolkit. At the end of this arm is a suite of sophisticated instruments, each designed to interrogate the rock in a different way. The science team first deployed an instrument called Sherlock. It's a remarkable device that uses an ultraviolet laser to scan the rock's surface. When the laser light hits certain types of molecules, it causes them to glow or fluoresce in a very specific way. By analyzing the spectrum of this glow, scientists can identify the presence of complex carbon-based molecules. It's a non-contact, non-destructive way of fingerprinting the rock's chemistry. As Sherlock began its scan, data started streaming back to the Jet Propulsion Laboratory in California. On computer screens, lines and peaks began to form, a chemical portrait of Cheyava Falls. And within that data, the team saw something astonishing. The signals were strong, concentrated, and undeniable. The rock was rich with a diverse class of organic molecules. These aren't just any molecules, they are the fundamental building blocks of life as we know it. Finding them is not the same as finding evidence of life itself, a crucial distinction. Think of it like finding a pile of bricks and lumber at a construction site. You haven't found a finished house, but you have found the essential materials needed to build one. For the first time, in this ancient lakebed, Perseverance had found a high concentration of the very ingredients for life, preserved in a rock that was formed in a once habitable environment. The discovery at Cheyava Falls was a watershed moment, confirming that the Martian rock record is capable of preserving the exact kinds of molecules we are searching for. The question was no longer the building blocks of life could be preserved on Mars, but they got there. These molecules, they're carbon-based, like the ones found in every living thing on Earth. And guess what? They were trapped inside that rock for nearly 3.7 billion years. The data sent back from Perseverance paints a tantalizing picture. In the fine-grained mudstone of this ancient river delta, scientists have found what they've been searching for decades: organic molecules. Now, it's crucial to understand what that term really means. It doesn't automatically signify life. In chemistry, organic simply refers to molecules containing a framework of carbon atoms, often bonded with hydrogen and other elements. They are the fundamental building blocks of all known life, the very stuff of our DNA, proteins, and cells. But here's the scientific catch: these molecules can also be created by geological processes that have nothing to do with biology. Interactions between water and rock, or even the constant rain of carbon-rich dust and meteorites over billions of years, could explain their presence on Mars. So, the rover hasn't found fossilized Martians. What it has found is something more subtle and potentially more profound. A clue, preserved for billions of years, pointing towards a possibility. The reason for the intense excitement is the context. These specific types of organic molecules were found concentrated in rocks, known for their ability to preserve fossils, in an environment, a calm lakeside setting, that was once undeniably habitable. It's like finding a pile of bricks and lumber next to a blueprint for a house. You haven't found the house itself, but you have compelling evidence that one could have been built there. For this reason, scientists believe this could be evidence of ancient microbial life, tiny creatures that once lived in Mars's lakes and rivers, long, long ago. If life did get a foothold, it would have likely resembled the extremophiles we find on our own planet. On Earth, life thrives in the most inhospitable places imaginable, in the boiling, acidic waters of geothermal springs, deep beneath Antarctic ice, and within rocks miles below the surface, completely cut off from sunlight. These tenacious organisms prove that life is not a delicate flower, but a stubborn weed, capable of adapting to conditions we once thought were sterile. Perhaps Martian life was similarly tough, clinging to existence in the cold, thin waters of a dying world. But to move from possibility to proof, we need more than what the rover can tell us from 100 million miles away. Confirming a biosignature, a definitive sign of past life, requires the power of laboratories here on Earth. That's why Perseverance isn't just a geologist, it's a courier. It has been carefully drilling, collecting, and sealing the most promising rock samples in pristine tubes, creating a geologic time capsule to be brought home by a future mission. Only then can we analyze them for the complex patterns and isotopic signatures that could scream biology and rule out any other explanation. And if it's true, if those samples confirm that life arose on Mars independently from Earth, the implications are almost impossible to overstate. It would mean that the origin of life, the process of abiogenesis, is not a one-off miracle that happened in a primordial soup on our world alone. It would suggest that life is a fundamental, perhaps even common, outcome of planetary evolution, given the right ingredients and a little bit of time. If true, that means life didn't just happen here on Earth. Suddenly, the icy moons of Jupiter and Saturn, like Europa and Enceladus with their subsurface oceans, become even more compelling targets. They too have water, organic molecules, and a source of energy. The search for life would transform from a hopeful quest into a systematic exploration. And beyond our own cosmic backyard, the possibilities multiply exponentially. We now know of thousands of exoplanets orbiting other stars. Statistically, billions of them could be rocky worlds in the habitable zone, where liquid water could exist. If life started twice, just in our solar system, then the universe is likely teeming with it. It could happen anywhere. The samples are sealed. Tiny fragments of an alien world, carefully chosen and cached by Perseverance, now await their extraordinary journey home. The Mars Sample Return Mission, a complex interplanetary relay race, is poised to bring these precious pieces of the red planet back to Earth. For the first time in history, we won't be studying Mars through the eyes of a robot. We'll be holding it in our hands, analyzing it in our most advanced laboratories with instruments too large and powerful to ever send to space. These aren't just rocks, they are time capsules from a 4-billion-year-old story. And inside these capsules, as we've seen, are clues that are rewriting that story. The discovery of a rich diversity of organic molecules within the ancient mudstones of the Jezero Delta is a watershed moment. Let's be clear, organic molecules are not definitive proof of life. They can be created by non-biological processes, but the complexity and distribution of the molecules found by Sherlock are tantalizing. They are precisely the kinds of building blocks we would expect to find in a place that once harbored life, the lingering chemical ghosts of a potential Martian biosphere. This raises the ultimate question: if life ever did take hold on Mars, could it have survived? As the planet's atmosphere thinned and its water vanished from the surface, life would have been forced to retreat. The surface of Mars today is a brutal, irradiated desert, but beneath the red dust, it could be a different world. Just as life on Earth thrives in the most extreme environments imaginable, from the crushing pressure of the deep-sea vents to the frozen hearts of Antarctic glaciers, Martian life may have become an expert in survival. We can imagine it now, microbial communities clinging to existence in salty subsurface brines, shielded from the harsh radiation, drawing energy not from a distant sun, but from the chemical reactions in the rock itself. Perhaps Mars isn't dead, but merely dormant, with its greatest secret still sleeping deep underground. And the search doesn't end on Mars. This quest for a second Genesis is pushing us further into the solar system. We're looking toward the ocean moons of the outer planets. Jupiter's moon Europa, with its vast subsurface ocean hidden beneath a shell of ice, could contain more liquid water than all of Earth's oceans combined. Saturn's moon Enceladus actively sprays plumes of its own subterranean ocean into space, giving us a chance to sample it without even landing. And the Dragonfly mission will soon send a nuclear-powered quadcopter to fly through the thick, nitrogen-rich atmosphere of Titan, exploring a world of liquid methane rivers and organic sand dunes. Each of these worlds offers a unique test of a profound hypothesis, that life is not a miracle, but a natural outcome of cosmic chemistry. Finding even the simplest microbe on Mars, or in the oceans of Europa, would be the single most important discovery in the history of science. It would mean we are not alone. It would transform our understanding of our own origins and our place in the cosmos, suggesting that the universe is teeming with biology, and that the silent starry night sky is actually filled with unseen possibilities. The next decade will be pivotal. The Mars sample return will bring the mystery directly to us. The European Space Agency's Rosalind Franklin rover is designed to drill 2 meters beneath the Martian surface, far deeper than any previous mission, specifically to search for those signs of life that may be protected underground. We are standing on the precipice of a new era of exploration, moving from asking, "Could there be life?" to actively seeking it out in the places it is most likely to be found. So, as NASA's scientists prepare to analyze these first returned samples, the story of Mars is far from over. In fact, the most exciting chapter may be about to begin. One thing is clear: Mars may not be as dead as we thought, and maybe, just maybe, something is still waiting for us, preserved beneath the red dust. Now, after seeing the evidence, the ancient landscapes, and the promise of what's to come, we turn the question to you. What do you think? Is Mars a sterile world of fascinating chemistry, or is it hiding the greatest secret of all? Comment with your theory below.